All right, this function is defined everywhere except for at 2, because when you plug in 2, you get 0 in this denominator. And it's also not defined at 0, because when you plug 0 in, you get 1 over 0 here, and that's undefined. So what we're going to do is, we're not really interested in 0 at all. I'm just saying that it's not defined there as well. So this is not going to be continuous at 0. However, when you plug in 0, you don't get 0 over 0. You don't get this, which means nothing cancels out at 0 when x is 0. But if you plug in 2, we do get the 0 over 0. We get 0 over 0 when you plug in 2, and what that means is x minus 2 should cancel out of this thing somehow. So we need to do a little bit of simplifying, just like we do with our limits. And to simplify a complex fraction, you multiply by the common denominator of the little fractions. Okay, so f of x is really going to equal 2x times 1 over x is 2 minus x over x minus 2 times 2x, which is the same thing as negative x minus 2 over x minus 2. There we go. X minus 2 times 2x. Now these x minus 2's cancel out. Awesome. And we get negative 1 over 2x. So f of x equals negative 1 over 2x everywhere except for at 2. So no problem. And that means is, since the 2's cancel, the x minus 2's canceled out, there's a hole at 2. And since there's a hole at 2, I can extend this by just plugging in that hole. I can make my new function g equal what the limit is as x approaches 2, and then the function will be continuous. Notice though, however, that at 0, this thing is still not defined. It wasn't defined up here at 0. It's not defined down here at 0. So 0, we cannot extend this function at 0 to make it continuous, because it's still undefined at 0, so there's nothing we can do. But the 2's canceled out, so my g of x is going to equal exactly what f of x equals in its simplified form. Let's write this in red. G of x is going to be negative 1 over 2x everywhere except for at 2. But at x equals 2, we need to define the function so the limit and the function equal each other. And as x approaches 2, f of x is approaching negative 1/4. So as long as this thing equals negative 1/4 at 2, then it's continuous, because the function equals negative 1/4 at 2, and the limit equals negative 1/4 at 2, and that was our condition for continuity.